Welcome back with another video on TryHackMe.com. This is Nazir and we are doing intro to infrastructure as a code, which is coming under infrastructure as a code module and is part of DevSecOps. So we're gonna continue from where we had left previously. We completed task 1 to task 3 and today we're gonna start with task 4. So we're gonna click on the view site here and let's continue with our task 4. Okay, so I'm scrolling down a little bit. Okay, immutable versus mutable. Immutable versus mutable infrastructure refers to whether or not changes can be made to an infrastructure. To define both, let's imagine we have a simple infrastructure, a virtual machine with a web server and an application. If you want to change this infrastructure, for example, deploy some application code to your web application, this code will mean your web application will go from version 1 to version 2. How might that look for each? Okay. Mutable infrastructure means you can make changes to that infrastructure in place. So in our current example, we can upgrade the application on the server it's currently running on. The advantage here is that no additional resources needs to be provisioned for this update. With the resources already being used, just needed to be changed. Where mutable infrastructure start presenting issues is, imagine your web application updates contain 3 changes, and whilst these updates are being made, one of the changes fails to apply. This is a common occurrence in the development, and deployment can occur for several reasons such as application misconfiguration or network through dropout. Now running on your server will be a web application version with 2 of the 3 changes required to be version 2. In other words, it's no longer version 1 anymore, but not quite version 2 either. Okay, this is a real scenario here. When an application is updated in a production environment, it will have been tested first in development and staging environment. What won't have been tested is this halfway version, leading to all kinds of potential issues. Imagine now that this update was not just rolled out on a single server, but many, maybe some updates succeeded, some failed with errors in different changes. You can see how this can become an issue very quickly with different versions of the web application existing across many servers or containers. So we can see that, okay, this report is all green and this report is all red, and this report is a little bit funnier. Okay, so immutable infrastructure means you cannot make changes to it. Once an infrastructure has been provisioned, that's how it will be until it's destroyed. Now let's apply that to our example. When this new version 2 of the web application is deployed, an entirely new infrastructure will be deployed with this new version. Now you have 2 infrastructure stood up, one with version 1 of the web application and the one with version 2. However, if all the changes are implemented successfully, and only if they all or otherwise, if it fails, the infrastructure will be torn down and the processes will be retired. The version 1 infrastructure can be torn down. This approach has some drawbacks, as having multiple infrastructures stood up side by side or retrying on failed attempts is more resource intensive than simply updating in place, but it allows for consistency across servers. You know that with the certainty that X server is running version 2 of the web application. So the immutability is the way to go, right? Okay. Immutable infrastructure as a code tool: Terraform, AWS Cloud Formation, Google Cloud Deployment Manager, Plumi. Some of these tools can be configured to be used with the mutable infrastructure, but work better with the immutable approach. In the example given, it makes more sense to use a immutable infrastructure. However, to demonstrate further that each can have its own use case. Imagine the server instead is a critical database system that requires regular maintenance, updates, and patching. If you were to use an immutable infrastructure for this, critical database would have to be rebuilt from scratch every time, which can be a risky process when dealing with business critical data. That is very true. So in this instance, it might make sense to use a mutable infrastructure. Sure. So here, for example, you are destroying one robot and adding one robot here, and they have the graphic for once you are destroying the robot, it is asking for help here, and this robot is still chilling. Provisioning versus configuration management. All right. All the characteristics discussed in this task so far are behavioral. In other words, how does this tool work? This way or that way, considering what a tool's purpose is and when it is used in the development of the infrastructure will tell us whether it is a provisioned tool or a configuration management tool. You might see these primary functions defined differently elsewhere. For example, infrastructure as a code versus configuration as a code. But to determine which tool falls into which category, you simply need to ask, what can it do? If we think about 4 key tasks: infrastructure provisioning, the setup of the infrastructure management, changes made to the infrastructure, software installation on that in infrastructure, initial installation and configuration of software applications, and software management, updates made to software or config changes. तो यहाँ पे क्या बताने की कोशिश कर रहा है कि आपका इंफ्रास्ट्रक्चर जो आप प्रोविजन करते हैं, फॉर एग्जांपल है वीएम के ऊपर कुछ सॉफ्टवेयर इंस्टॉल करने पड़ेंगे, जैसे कि IaC टू होस्ट योर वेब सर्विस, और फिर एक तो ओएस के अपडेट्स होंगे और एक सॉफ्टवेयर के इटसेल्फ अपडेट्स होंगे, और फिर एक अपडेट्स होंगे आपकी एप्लीकेशन के. तो ये सारी चीज़ें बताने की यहाँ पे कोशिश कर रहे हैं. There is no single tool that can perform all 4 of these tasks. Instead, combining 2 tools, a provisioning tool and a configuration management tool, is common practice to cover all these. There will be a practical example of exactly what tools can cover which task in the static site coming up. Some example of each type of tool: provisioning tool, Terraform, AWS Cloud Formation, Google Cloud Deployment Manager, and Plume. Configuration management tool are Ansible, Chef, Puppet, and SaltStack. Let's consider a real-life industry example of how these 2 types of tools might be used. Say you work for a company which needs to set up a new infrastructure for a web application. A similar one has been deployed before and fell prey to some malicious activity. So this time you will install an agent to monitor for this activity. The infrastructure would be defined and provisioned using a provisioning tool like Terraform, and then a configuration management tool like Ansible would be used to install an agent within the provisioned infrastructure to monitor for malicious behavior. Put that all together. Okay, now you have been introduced to the world of the infrastructure as a code tool. Yeah, but I mean, we didn't practice anything, right? We just go through the theory itself. And their various uses, each has its characteristics which best suit different use cases and scenarios. In that way, they are no different to physical tools. We have to assess the problem and choose the best tool to address it. Here's a little summary of what we have discussed, as well as a little bit more information about some of the tools mentioned. Okay, Terraform is a declarative agentless infrastructure provisioning tool that works with immutable infrastructure. Terraform is one of the most popular infrastructure provisioning tools out there, allowing for the management of the infrastructure across multiple cloud providers like AWS, GCP, and Azure. Okay. Plume is a declarative. We know about the declarative and the imperative one. Is a declarative agentless infrastructure provisioning tool that works with immutable infrastructure. Plume is similar in nature to the Terraform, but has become increasingly powerful in recent years due to its ability to let users define their desired infrastructure using familiar general purpose language like Python, JavaScript, or Go, Java, and markup language like YAML. AWS Cloud Formation is a declarative agentless infrastructure provisioning tool which can be used to implement an immutable infrastructure on AWS. This is an AWS managed service and provision AWS cloud resources using JSON YAML templates. Okay. Chef is an imperative agent-based configuration management tool that works with the immutable infrastructure. Chef gets an infrastructure to a desired state by running a series of instructions contained in a file referred to as a recipe. A collection of these files is referred to as a cookbook. Puppet. Puppet is a declarative agent-based configuration management tool that works with mutable infrastructure. In Puppet, you define the desired configuration state using their own domain-specific language, DSL. Puppet code. Puppet then automates this configuration through a Puppet primary server and agent. So this is how the tool should look like. We have tool, declarative or imperative, agent-based, type, and cloud agnostic. We have Terraform, which is declarative. Agent-based, no. Infrastructure provisioning, cloud agnostic, yes. That's why we go for Terraform. Ansible supports both imperative or declarative. Agent-based, no. Configuration management tool and cloud agnostic, yes. Plume is declarative, no. Infrastructure provisioning, yes. AWS Cloud Formation, it is declarative. Agent-based is no. Infrastructure provisioning, no. AWS only. Cloud, Google Cloud Deployment Manager, declarative. Infrastructure provisioning, no. Google Cloud only. Chef, imperative. It is agent-based configuration management, yes. Cloud agnostic. Puppet, declarative, yes. Configuration management, yes. Salt Stack, support both, yes. Configuration management and cloud agnostic, yes. So I think most of people are using, I think, Terraform and Ansible. They are also using Chef and Puppet, I mean. But I know that Terraform and Ansible are very popular. Static site scenario. This year in 2029, okay, the destroyers have risen from the ashes of the nuclear fire brought on by Flynet, an artificial intelligence that has gained sentience. This destroyer have one objective: to destroy humankind. The resistance is led by Ron Corner, who has just received intel that the machines have discovered a technology which allows them to send a machine back to 1984 and kill his mother before he is born. Not cool. Ron Corner needs this technology to send his finest Sergeant Miles Kreese back to 1984 to protect his mother. The only problem is he needs to figure out where to find it. After a successful skirmish, Ron Corner has managed to get employee access to Flynet terminal, boot up the static site, bypass the employee training, and retrieve the location info he needs. What could go wrong? Okay. This is don't feed the machine, beat them, join the resistance. Okay. So this is a war brochure. Okay. Can retrieve the location and retrieve the flag. Sure, we can start it here. Hopefully we'll be able to do something. Drag and drop the correct item into the box. Okay, provisioning and configuration management. Okay, so let's go back to our tool here. We'll use Terraform. This one to provision the infrastructure. Configuration management, we can use Ansible here. Okay, what else? Okay, okay. So we need to keep on going. Plume is infrastructure management. Okay, and then we have AWS CloudFormation is infrastructure provisioning. And then we have Chef, which is configuration management tool. This is Salt Stack, which is configuration management tool. And this is Google Cloud Deployment Manager, which is infrastructure provisioning tool. And then we have Puppet. Puppet is basically configuration management. All right, continue. Okay. Instruction: pick a combination of a tool which will cover all tasks. Each tool will light up the task that type of tool generally covers. Okay. Tool 1, tool 2. Infrastructure provisioning, infrastructure management, software installation, software management. Okay. So first of all is tool 1. Tool 1 will do what? Okay. Pick a combination of tool which will cover all the tasks. Each tool will light up once that type of tool generally covers. Okay. Okay. Now we need to have a software management. That means we can use Ansible, maybe. Ansible. Yeah. We can continue. Awesome. Information is starting to download. Please wait until the download is complete. Okay. An error occurred. The machine has been made aware of the user's presence. You must defend the computer as the download completes. To play the game, follow these instructions. Select an enemy. Read the question at the bottom of the screen. Choose a weapon that matches the question. Move the player left or right using the arrow keys. You can also use A, D, or HL to move. Press the spacebar to shoot. If you miss, the enemy will move faster. You can press the information button located at the bottom right of the game area to view this information. Okay. All right. Select the enemy. This is the enemy. I'm selecting the enemy, man. Okay. Enemy is what? I will use, for example, Ansible, and machine is gone. Now this is the enemy. I will use agentless agent base imperative. Okay. Uh, Project planning, disaster recovery. Declarative. Readable. Ah, shit. So what will I do? I will try it offline, and once I complete it, I will come back. So this is how I win. I get the flag here. So what we needed to do is just play the game. Just look at this table here, and the question will appear on the bottom. You just need to answer the question based upon the tool we select. So what will I do? I will just put it here, and we can do another go here. Okay. So I will submit. All right, we have with another streak, 21st. Okay, I will play it again just to make sure that you understand how we'll do. Okay, oh, it will start from the beginning. So I will not play it here. Let's move on with the next task, guys. Okay. So we'll cover task 5, and once we come back, With another video, we'll start the task 6, 7, and 8. Okay, let's move on. Infrastructure as a code lifecycle. The lifecycle. Now that it has been established and what IaC is and the tool we use to implement it, it's time to define the lifecycle. There is talk about an IaC lifecycle across forums and blog posts and academic papers. Still, there is yet to be an agreed upon and widely adopted lifecycle as there is for DevOps or DevSecOps. And because we think you, the reader, and would benefit from having an infrastructure as a code lifecycle to use as an educational tool, we have defined one, the infrastructure as a code lifecycle, IaCLC. The actions tasks performed by developers and IaC tools can be broken down into phases, which together make a lifecycle. This lifecycle helps us understand that infrastructure as a code has continual and repeatable processes, which don't simply follow a linear sequence of provision and management tasks. This task will outline the stages of the IaC lifecycle, its phases and how they are connected. Okay, so they are trying to say that there is no known agreed upon lifecycle steps here. So what they did, they created for us, which could be used as a as an example to improve upon. So this is what they have provided us. So before we do that, let's understand the theory here. Infrastructure as a code lifecycle is designed to give DevOps engineers or anyone else assigned with the task guidance on the task associated with the provision and infrastructure and continued support of that infrastructure. Key DevOps practices such as continuous integration and continuous deployment are also part of the best practices throughout the lifecycle. Due to IaC being a development process, some parallels can be drawn between IaC lifecycle and SDLC, which also covers a solutions, planning and designing, implementation, testing, deployment, and monitoring. While these parallels exist due to these lifecycle being created on the same foundation, providing developer guidance and improving output quality, they don't directly fit into each other. Both life cycles break down tasks into phases. However, due to the frequently changing infrastructure needs, the IaC infrastructure as a code life cycle distinguish between two different types of phases. So we have version control, collaboration, we have monitoring and maintenance, rollback, review, and refactor. And here we have design, define, test, provision, and configure. Breaking it down. As mentioned above, three phases are separated into two types. Let's break them down. Continual best practice phase. Okay. These phases are continually done to ensure best practices throughout the various stages of infrastructure development and management. Continual phases can trigger repeatable phases. Okay, so the continual phase is this one, rollback or review or refactor. We have two here. Repeatable infra creation plus config phases, which is mentioned by the arrow. We have design, define, test, provision, and configure. These phases are done during the creation and configuration of an infrastructure and done one or many times at different points and with differing variation depending on what needs to be done. Some examples are below. Activity, entirely new infra, design, define, test, provision, configure. Activity config change. So we already had designed, we already have defined, we just need to test the change. Provision is already there. Continual best practice phases. We have version control, collaboration, monitoring, and maintenance, rollback, review, plus change. So let's see what we have here. The phase involve versioning code while defining your infrastructure and making changes. This way, when it comes to the later rollback phase, there are clearly defined versions to fall back on should a new change break something. Okay, so for example, version 1 could have some service which is provisioned Version 2 could have some update of that service. So if you need to roll back to the previous one, you already have code to do that. Okay, so it will be in the context of mutable and immutable. So we lean towards immutable infrastructure. Okay, collaboration. When working as part of a team on infrastructure, it is crucial to communicate and collaborate so everyone is on the same page. Otherwise, this can lead to a disconnect between modular infrastructure component or general confusion over infrastructure. Okay. So communication or collaboration is a part of it, as you mentioned, and it is crucial to communicate and collaborate so everyone on the same page. Okay, monitoring and maintenance. Once an infrastructure has been provisioned, configured, it must be monitored for poor performance, security events, failure events, warnings, etc. Automated maintenance tasks, e.g., disk cleanup, can help avoid some of these events. In certain events, this phase can trigger the rollback phase. All right. So the monitoring and maintenance phase can trigger the rollback phase, which is the next one, rollback. In the event of a failure event post deployment, the infrastructure will need to be rolled back to the last non-working version here. That's why we need to have a version control for infrastructure as a code as well. Review plus change. Just because an infrastructure works does not mean it's as efficient as it could be. Perhaps a new security vulnerability has been discovered, or maybe there is a new business requirement that would benefit from an infrastructure change. Infrastructure should routinely be reviewed to determine if this is the case and change if so. So we will review it. If everything is working fine, we are good to go. If there is a security vulnerability discovered, then we may need to come up with some change, or if there is a business requirement which will require a business the infrastructure change. So this particular task, review plus change, we'll do repeatedly, okay, as per the schedule or whatnot. The repeatable infra creation process config phases. Okay, we have design, define, test, provision, and configure, which is repeatable. And this is continual. Okay. This is for entirely new infrastructure, and this is for config change. Okay, so we covered the continual best practices phase, which was this one, just to maintain everything. And now we're covering the repeatable task. All right. So the repeatable infra creation plus config. Infra creation plus config mean changes that will be applied on the infrastructure. Design. The infrastructure needs to be designed based on needs, taking security into account throughout the whole process. For example, poor scaling policy design can lead to availability issues, which is a huge security concern. So poor scaling policy design can lead to availability issues. So if you are designing a solution which should be highly available, and if the solution is not designed to be highly available, then there could be an issue. Okay, availability issue, maybe if you did not consider the security while designing the solution, then security concern could raise up later on. Okay, define. Use the design to define the infrastructure that needs to be provisioned. For example, you need 2 VMs for AD, 2 VMs for controller, 2 VMs for load balancer, 2 VMs for database, 2 VMs for your web application, like that. So you are covering like high availability here. Okay. Now for security, we need to cover security of the application using SAT and DAST. Okay, if you're deploying it on VM, then we need to cover the security of the VM itself and all the layers. For example, network layer, the ports needs to be closed. Okay, if you are going for the containers, then we need to consider the container security, and we need to use all the tools that we have covered in this learning path. Okay, so that the images don't have the vulnerabilities, and also the container is configured correctly For example, Docker engine is configured correctly. If you are using that, if you are using Kubernetes, then it is configured correctly and secure. So all of these, there is a lot of work, I mean, in the DevOps and DevSecOps, especially on the once you consider the security itself. Okay, and security is paramount now. Everybody's focusing on security. Even as per the report by the top IT companies in the world, the number one item that they will invest in is the security. And guess where the AI is? AI is on number 4. And this is the report for 2024 and onwards. Define. Use the design to define the infrastructure that needs to be provisioned in the code. Yes, we already covered that. Test. Using a linter, validate the code for syntax errors or logical issues before provisioning is done in production. Test the infrastructure in a replica environment staging. Okay, see. This is very, very crucial. Test the infrastructure in a replica environment that will be deployed on production. As you know, the CloudStrike issue was happened because one of their linter was failing to detect that there is a null reference within the code that will be deployed to their servers. Okay, that was what they had mentioned. So if you are not testing using a replica environment, maybe staging, maybe pre-production, what they were doing, they were just linting it and deploying it to production. That's it. They were not, I think, doing the test infrastructure as a replica environment. Okay, so they are saying that this is the the outage that was there because of the CloudStrike was so huge that this level of outage never happens before globally. Okay, so we got to know more about the CloudStrike, what happened, what does not happen. They already put a published version of what happened online. You can go and search about it. You will be able to understand all of this. Right, so test is very, very important if you consider infrastructure as a code and not use linter is okay, but you also need to deploy it and test it. Exactly, that will be done in production. You need to test it in a replica environment, maybe staging, maybe pre-production, whichever environment is there for you to test. Right, provision the infrastructure that has been defined in the production environment using a provision tool such as Terraform. So Terraform is cloud agnostic. You can use Terraform to deploy your infrastructure or provision your infrastructure. And once the infrastructure is deployed through Terraform, you can use Ansible tool to configure the environment itself. Okay. Right, because this is a configuration management tool, so you can provision the environment itself there. For example, what software needs to be installed, what ports needs to be open. All of this configuration can be done through the Ansible, and Terraform will help you deploy the tool set itself. Okay, so if we go up in the previous table here, we know that it is agentless. Terraform is agentless and Ansible is also agentless. Okay, so Terraform supports declarative, Ansible support declarative and the imperative. Okay, so you can define the infrastructure provisioning and configuration management, and they are both cloud agnostic. So this is a very good set of tools to use together. You can use also Chef, by the way, for configuration management. Instead of Ansible, you can use Chef. Terraform is, I think, a go-to tool for provisioning the infrastructure. Plume is also a good way to go, but it is also declarative. Most of the tools are declarative, as you can see, declarative for infrastructure provisioning. But for configuration management, you can use either declarative or imperative. So we are using Terraform and Ansible. Let's move forward. All right. We are here. So provisioning we are doing with Terraform, and configuration of the environment itself is with Ansible. And here is our infrastructure as code lifecycle in action. We do the version control, version 1. Collaboration, we tell everybody that, okay, this tool will be used and these are the roles of the tools. Okay, so let's move forward. Everybody knows what we need to do. Once we deploy, we monitor and maintain for changes to the infrastructure, for alerts, security alerts, or any other alerts or errors. Okay, so based upon the alerts, we decide either we need to do the rollback. So rollback will be done based on the version control. So for example, version 2 is having some problems, so we can roll back to version 1. Okay, that's why the version control is very, very important. Then we have review and refactor based upon the business requirement, or maybe security requirement, or anything, any factor else which will impact our business or the infrastructure. We'll review and refactor and change our infrastructure configurations, which is a repeatable process here. So this is CyberMyne. Okay. Now here, first we define what we need to create. Okay. We need to design it first. In design phase, we also take care of the security, high availability, and all other non-functional or functional requirements. Then we define what will be created. For example, the actual resources that will be created, VMs, LANs, network, or whatnot. Then we test it, everything is working fine. Then we provision it. And then provision mean if we need to provision, for example, dev environment, staging environment, production environment. So we'll use the Terraform to provision it. Okay. Because it is cloud agnostic, so we can provision the infrastructure anyway. And then we configure the infrastructure that we created, the environment itself, we configure it. For example, which port will be opened on the OS, and the software that we need to install. All of this will be done through Ansible, and both of them are agentless. All right. Let's move on with the question and answers. We are already 37 and passed into the video. So I think let's continue with these questions, and once we'll come back, we'll go with the task 6. A DevSecOps engineer at CyberMyne is looking for guidance on developing their next infrastructure. What type of phases provide guidance during the development or configuration of the infrastructure? What phases? What type of phases? Okay, what type of phases? So I think continual. Not sure what to say. No. Wait a moment. During development and configuration. So development and configuration is this one. Awesome. Yeah. Okay. What type of the phases ensure best practice throughout infrastructure? So the best practice is the repeatable one here. And here is the deployment and configuration. So best practice is here, continual. Continual is best practice, and infrastructure creation and config is repeatable. All right. The monitoring and maintenance continual phase can trigger which other continual phase? Rollback. Awesome. So thank you for joining me on this journey, guys. If you like this video, I know there is a lot of theory, and it is a kind of dry concept for now. Stay with me. I think once we move to the next room, it will be really, really enjoyable. For now, it is okay. As you can see, the creator is also Max Robertson, because before it was CM Natic or somebody. And also the room is very, very new, and they are still improving it. Okay. So if you like the video, please give the thumbs up. If you haven't subscribed, please subscribe. And if you have any suggestion, please put it down below in the comments, and I will see you in the next video. Bye bye.